Hi guys, let's look at quiz 1 here. Name, course section 8 through Z. How about that? Okay, provide an acceptable Lewis structure for a neutral compound with formula there. Of course, all lone pairs and formal charges should be shown. Number of valence electrons. Each carbon is 4, that's 8. 4 more is 12. Bromine is 7. Nitrogen 5. Oxygen 6. What would this be? 9 and 15 and 20. 30 valence electrons. DUS, oxygen ignored. Bromine adds an H, but nitrogen subtracts an H. So these pretty much cancel each other out, so we can pretty much ignore all of that. C2, 2n plus 2 would be 6. We only have 4 H's. We're missing 2. That means there's 1 DUS. Okay. From there we can put together a structure. Line bond is okay. Maybe we need a DUS here, maybe a carbon-carbon double bond. Boom, boom. Then we can add, there's our 1 DUS, the rest must be saturated. We can come in here with maybe nitrogen. Then we could bond this to the oxygen. You cannot have a double bond here. Oxygen needs another bond. We can bond this to H. Nitrogen needs another bond. We could bond that to H. Lone pairs. We need to add a bromine. We can add a bromine maybe over here. Replace this H with a bromine. And we want to put 3 lone pairs on the bromine. 2 carbons. A bromine, nitrogen, oxygen. 1 DUS. Should be the right number of hydrogens. 4. 1, 2, 1 here, 3, 1 there, 4. Numerous structures we could draw. Just show you another one. Maybe instead of a pi bond, carbon-carbon pi bond, maybe a ring. Maybe carbon. Maybe to then oxygen. 3-membered ring with 2 carbons and an oxygen. Lone pairs on oxygen. Our 1 DUS is there. The rest has to be single bonds. We can bond here maybe a bromine with 3 lone pairs, and then maybe over here a nitrogen. Well, the nitrogen has to have 2 other bonds. It's going to have to be H's. We've used the carbons already. We've used the oxygen and the bromine, but we can put H's here. And a lone pair. Typical bonding. By the way, was this 30 valence electrons? No doubt it was, because we got correct bonding, but we can double check that. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 2, 4, 6. What's up here? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 2, 4, 6. What's going on here? 6, 5, and 7. 2 carbons is 8. 4 is 12. 12 and 7 is 19. 19 and 11 is 30. Two, 4, 6, 8, 10, 12. Oh, I see what's going on. I see what's going on. I'm not counting the electrons in these bonds to H's. Okay, I was like, okay, can I add? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. But there's 2 electron bond here, 28, and a 2 electron bond there to the other H, 30. Okay, yes, 30 valence electrons. Should be 30 here. Correct number of H's here, 1, 2. There's 1 H here, and there's 1 H here, for a total of 4. Okay, there's lots of other structures that could be drawn there, each with 1 DUS. Functional groups, well, that's an ester. Okay, we got a carbonyl, carbon on one side, O carbon on the other. This over here is very similar, carbonyl, carbon on one side, OH on the other. That's a carboxylic acid. This is an ester. This one, though, is the one we need to name. This is an amide. Long name being carboxamide or carboxamide. It is tertiary. You don't necessarily have to put that, but just to clarify, it's a tertiary amide because the nitrogen is bonded to 3 carbons. Questions. Weakest carbon-carbon bond, A, B, C, or D? Basically, we need to know what type of orbitals are being used to make the bond. This is sp2, sp2. This is sp2, sp3. This is sp3, sp. Okay, sp3, sp. This one here is sp3, sp3. Not much room to write here, but what I see is that the sp3, sp3 bond is going to be the weakest. Also the longest. And longer usually corresponds to weak. Weaker if we're dealing with the same atoms in the bonds. It's weaker because the orbitals or the electrons that are used to make the bond are higher in energy. They're higher in energy because they're sitting in orbitals that have less s character. The weakest is D. Degrees of unsaturation. I see 2 rings. And 1, 2, 3, 4, 5, 6 pi bonds for an answer of 8. Because an alkyne has 2 pi bonds, and then pi bond here. Double bond is a sigma and a pi, but number of pi electrons, that is electrons in p orbitals. Well, each pi bond is a 2-electron covalent bond. It's 1 electron from each, 1 electron in the p orbital, 1 electron in the p orbital overlapping to make pi bond. So a bond is a 2-electron covalent bond by overlap of certain orbitals. 2 electrons, 2 electrons, 2 electrons, 2, 4, 6, 8, 10, 12. So the 6 pi bonds, that's 12 electrons. But we also have pi electrons here, because one of these lone pairs is going to want to be in a p orbital because there's a p orbital next door. So that lone pair is in a p orbital to give us an answer of 14. 2, 4, 6, 8, 10, 12, 14. No other lone pairs in a p orbital. The other lone pairs are in sp3 orbitals. Answer the following questions. Considering every atom is neutral, how many lone pairs? 2 on oxygen, 1 on nitrogen, 1 on nitrogen, 2 on oxygen. Ooh, how many on that sulfur? 1 here, 2 here. Every atom is neutral. For this sulfur to be neutral, it would only need 1 lone pair. Now it's neutral. Now it owns 2, 3, 4, 5, 6. It's supposed to own 6. That's neutral. That's an expanded octet sulfur. So it's not typical. It's not like a typical oxygen in this case. And there's only 1 lone pair there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 lone pairs. The lone pair of nitrogen A is in what type of orbital? This is in an sp2. sp2. That's a standard nitrogen, nothing funny going on here. We have 3 electron regions. Okay. If we graph this, it's sp2 with a p orbital left over. I see a sigma bond to carbon, a sigma bond to carbon, and a pi bond to carbon. And that's the double bond. And then the lone pair has to be in the hybrid sp2 orbital. The p orbital is being used to make the pi bond. Net charge of the following drug molecule. Fluorine is neutral. Standard halogen, 1 bond, 3 lone pairs. This oxygen, not standard. It owns 2, 4, 6, one of those 7. It owns 7. It's only supposed to own 6. So it's got 1 more than it's supposed to have, so that's an anion. It's a negative charge because it has an extra electron. This oxygen is standard, 2 bonds, 2 lone pairs. You can do the charge, it's neutral. What about the boron though? Boron is supposed to have 3 electrons from the periodic table. How many does it own here? Owns 3. It's supposed to own 3. So that boron's neutral. Everything is neutral here. We've got 1 anion. The net charge is -1. Now, if you have this medication, or if you have this compound, most likely a solid, it has to have some type of positive with it, such as a sodium ion. You cannot just have a negative molecule. It will have some type of ion with it. Okay. There's the quiz. And this will be posted on the 3rd floor.